Hello, Assalamualaikum. My name is Muhammad Luman bin Jeffrey, CF22021. Okay, this video is belong to our group, which is our group number 2, and for the topic is application of differentiation and integration. For the introduction, first of all, I would like to thanks to our lecturer, which is Dr. Nurang Izzati binti Muhammad Yassin for the project opportunities. Okay, this project for preparation for the final, and this task will complete by every each of group members. Okay, problem number 1, plot graph of volume versus time and average speed versus time. Okay, group 2, location site A in front of the College Kemahiran Tinggi KKTM Sri Gading, and for the date 26 January of 2021 and time 10 AM to 12 PM of peak. Okay, that is as you can see in the slide, the table that given to us, which is time, density, average speed and volume. Okay, solution problem number 1. Given the table, time and volume, we conclude the data and the graph should be like in the slide. Right, equation from the graph number 1, we get x 61.513, then the point x is 493.287. Okay, from this differentiation of function, we get decrease, increase and decrease. Okay, for the first tested value, we put 20 and we get negative, and then one we put 70 and we get positive, and then for the last one we put 500 and we get negative. As you can see in the slide, we got our graph table. We have x-axis, y-axis, 15 minutes interval and rate of change. Okay, followed by the formula. The first S we put 15, we get 264.577. The other one is 30, we get 231.469, and for the last one, x-axis is 211.726. And then look at all the relative maximum and minimum number. First relative maximum point, we get 15264.577, and the rest will follow by. And then the one with relative minimum point, we get 45.211.76, and the rest will follow by. And for the last answer is evaluate the absolute maximum and minimum number. The first absolute maximum number is 120.285.139, and the last one is the last absolute minimum number is 60204.358. That's it for me, and let's go for the next.
I will resume my presentation to 1B, which is plot graph or average speed versus time. The table, we can see that time is in minutes and average speed is in kilometer per hour. From the table that is given to us, we can create the graph like this, and the question said that we should find the intervals whether it is increasing, decreasing or constant. And our equation from the graph is y equals 2 times 10 power of negative 5 x cubed minus 0.0028 x square plus 0.082 x plus 72.379. And fx equals to y, or function is equals to y. From the equation from graph 2, we differentiate the equation, we get 6 times 10 power negative 5 x square minus 0.0056 x plus 0.082, and function is equal to 0. Rearrange the equation and factorize it, we get x equals to 91.845 and x equals to 1.488. So we have 2 points, and the test value we pick is 1, 50 and 1000. For 1000, for the first test value is which is equals to 1, just insert it into the equation, and then you will get a positive value which is increasing. The sign of first differentiation for the function is increasing. And insert value 50, we get negative, which is decreasing, and insert value 1000, we get a positive value. From table 6, which is the table we just create. The function is decreasing in interval, which is 1.488 and 91.845, and increasing in intervals of negative infinity 1.488 and 91.845 positive infinity. Assuming question number 3 is rate of change for each 15 minutes interval, insert value of x into the equation. If the equation is function equals to y, which is the equation from graph 2. So 15 minutes interval, which means x equals to 15, x equals to 30, x equals to 40, and plus 15 plus 15 plus 15. To get the value of y, just insert the value of x, and then you will get the y. So for 15 minutes interval, you will need only 15. So 30 minus 15, 45 minus 30, 60 minus 45, and the sum of it will get 15. And then the rate of change is y1 minus y2 over the 15 minutes interval, and then you will get the rate of change. For the fourth question, for the fifth question, it said that locate all relative maximum and minimum number. For the question that is locate all relative maximum and minimum number, for the first relative maximum point is 1571.9395, and then you just etc. For the relative minimum point is 30.730 and 70.945, and then etc. And the last question is evaluate the absolute maximum and minimum number. For the absolute maximum number, you will get 120, 67.603, and the absolute minimum number is 90 and 65.017. That's all for my part, which is question 1B, and I will leave up to my friend for the next question.
Assalamualaikum, my name is Adi Ikhwan Bizan Abidin. Metric number is CF220114. So I will explain about my part, which is problem 1, question 3, about the cumulative volume versus time. So first, in order to find the cumulative value, I list down the data of time and volume given from the table question. Then I stated the first cumulative volume as 260 in order to find the next cumulative value, plus the current cumulative value. For example, 260 plus 244 to get 504. Then repeat the same method. After done getting all the cumulative volume data, plot the graph cumulative volume for y-axis versus time for x-axis according to the data. Then I create a table for rate of change by list down the x and y value, then identify 15-minute interval by minus the value of x2 minus x1. After that, find the rate of change by y2 minus y1 divided by x2 minus x1. Then you will get the value of rate of change. For example, 504 minus 206 divided by 30 minus 15 equal to 16.267. Lastly, I need to find the average for the rate of change. To get the average value, use all the data of rate of change, then divide with 7 the amount of data, then I will get 15.590 VEH per minute. That is all from me. Next slide.
Okay, I will present a solution for problem 2, which is method 1. Problem 2 has two methods, which is method 1 and method 2. So I will explain more about method 1. It is based on the question, the energy of the concrete can be calculated by using method of portioning the area under the graph, which known as trapezoidal rule, to find the approximate value of definite integral. So this is a graph of flexural strength Kn versus deflection M. So my group and I sketch this graph, and it is how look it's like. Okay, for the area of each portion, there are 7 portions labeled with A1, A2, A3, A4, A5, A6, and 7 to be calculated each of the area by using trapezoidal rule method as the manual calculation for finding area under the graph. Then, the area of each portion will be summed together to get the whole area under the graph. This technique is much more accurate way to approximate the beneath a curve. Okay, the first one is area of a triangle, which is 1 over 2 b times h, and the second one is 1 over 2 x2 minus s1 times y2 minus y1. The second formula of area of trapezium is 1 over 2 a plus b times h, and the second one is 1 over 2 y2 plus y1 times x2 minus x1. From the table, we calculate A1 until A7 to get their area under the graph. And that's all from me. Thank you.
Now we go to the method 2 of the problem number 2. Method 2 requires us to add a polynomial trend line on the graph, which will then automatically generate the approximate function required to evaluate the area under the graph. By adding a trend line of polynomial and linear with order 2 and equation obtained with for equation 1 negative 4 times 10 with a power negative 7 times x power 2 plus 0.0051 times x minus 1.4455, and for the equation 2 we got 0.0041 x minus 1.0544. Then we conclude the detail of information that we got into the formula, and we got boundary from 7.56 times 7 with a power negative 4 until 2.1 times 10 with a power negative 4, and in check we can enter the equation 1 and 2 into the formula, and we got negative 2.9567 times 10 with a power negative 4, and then minus with negative x.2131 times 10 with a power negative 5, and we got the answer negative 2.1354 times 10 with a power negative 4. Now we got the integration method. In the conclusion, first of all, we got the integration method that more effective than the trapezoidal rule method. This is so that the integration technique can give the proper value in terms of both area and volume. Lastly, the trapezoidal rule technique determines the value by employing an estimating region beneath the graph. In conclusion, when we accomplish this calculus project, we got that calculus is an essential part of building engineering. When we use differentiation to pick up problem 1 and to integrate the answer of problem 2, that we got the information from site A, which is near College Kemahiran Tinggi Marak, KTM, Sri Gading, For the initial challenge, we can determine the average rate of change in the cumulative volume VEH BS time. For the second issue, for normal concrete density 2400, we got two methodology, and from this methodology we know that a project challenge need and a big scale in Excel in order to solve the graph problem. That's all from group 2. Thank you very much.